So this is the part 2 of 11.9 where we are going to talk about derivatives and integrals of power series. So what do you mean by this? Now in the last part of 11.9 we learned that like functions like 1 plus x can be very nicely explained. Rational functions with denominators can be explained as power series, right? Now in that, in the last part, right? Last part we did that, right? And then using this, we actually got things like 1x over 1 plus x squared, and etc. etc. We were able to expand it as power series. Now there's a really neat trick which says that if you do have a power series, right, of a function within the radius of convergence, within the radius of convergence, you can integrate and differentiate which is kind of cool because it'll probably help you to get uh, a new functions. Okay, so let's do an example right away. Okay, so let's try to find the power series. Okay, 1 over 1 minus x squared, right? Now we know that this is actually the derivative of a familiar function, right? Okay, so we know that, for example, if you take 1 over 1 minus x, and if you take the derivative of that, what do we get? We use the quotient rule. You get 1 minus x times the derivative of 1 is 0, minus 1 times the derivative of this is negative 1 over 1 minus x squared, right? So you get negative negative 1. So this is 0 from here, and you get a negative of negative 1, which is positive 1 over 1 minus x squared. So really, this is the derivative of 1 over 1 minus x, right, which is exactly this. So if we can find the power series for 1 over 1 minus x, and if you can differentiate, we should get this, right? So easy. So we already know the power series for 1 over 1 minus x. This is our standard power series, right, which is x to the n, the geometric series, and which is valid when absolute value of x is less than 1. So what we do is we differentiate both sides. Remember, you can only do this inside the interval of convergence, right? So when you differentiate this side, you get 1 over 1 minus x squared. And then when you differentiate this side, you get nx to the power n minus 1. Okay, and that is, we are losing the power rule on that. And that is, okay. So you can kind of write it out if you like, if you don't like it like this. So put n equals 0. Uh, well, it doesn't make sense when n is x equal to 0, because then you just get the derivative of 1, which is 0. So this has to start from 1, remember, okay? The derivative of 1 is just 0, so it has to actually, I mean, if you put 0 here, right, you're going to get 1, and the derivative of 1 is 0. So this actually starts from 1, okay? So if you put 1, you get 1 times x to the 0, which is just 1. Put 2, you get 2 times x, plus 3, you get 3 times x squared, plus 4 times x to the cube plus. Okay, so that is 1 over 1 minus x absolute square. So this is the power series that you want. All right.